Hello, my name is Pankaj Dhote. I'm working as scientist at Indian Institute of Remote Sensing, Dehradun. It is unit of Indian Space Research Organizations. My presentation topic is the estimating river bathymetry from spaceborne lidar data and the curved fitting method. So river bathymetry, if you see, it is a crucial parameter when we try to do different studies. Maybe it could be flood mapping, habitat assessment, or the navigation. However, if you see for most of the rivers or in the ungauged basins, it is very rare to have this bathymetry information at the different cross sections. At the same time, whenever we try to use the satellite observations for flood modeling to account for the channel and the floodplain elevation information, we rely on the spaceborne DMs. You have different spaceborne DMs, like you have this Cartosat, then you have Allos Pulsar, RTC product, you have this FabDM Copernicus. So here you can see just the comparison. So this is the elevation information at a particular cross section, where green represents the elevation from the DM and this pink color represents the elevation information from the ISAT2 data. This is the specific case where we had the water very clear and the luster bit. That's why we could get some photon returns from the river bed. But this is may not be the case where you will always get this kind of photon data set where you will have the returns from the riverbed. So that's why in this case we have developed this particular workflow which works in the 4 stage by exploiting the spaceborne lidar ISAT2 data to know the river bottom at the ungauged location. Here you can see this is the specific case for the Mississippi River. This is the raw data set. Now this raw data set have a lot of noises. What we did is we did DB scan algorithm and did the different clustering. Now again, after clustering, all the point clouds are divided into the different clusters. And then from that, by giving certain rules on the density of the photon clouds, we had this left bank, right bank, and then water surface, and then further we have this smoothened after ample filter left bank and the right bank. So this is basically the representation of the dry bathymetry. We use this dry bathymetry information to extract water surface elevation and the width pairs, and these pairs we use to develop this non-linear slope-based model, and which allow us to get the information of the unknown parameter as the unknown bathymetry. That is, we also call it the wet bathymetry. So by combining this two, this dry and the wet, you get the complete attestation cross section. So this is the generalized methodology how you can get the river bathymetry. If you want to know more, you can always contact me.